We're going to go through a few important properties of trig functions. And the first thing I want to talk about is the domain and the range of the 6 main trig functions. So the first one, which is important, is sine of theta. And if you think about what the unit circle looks like, what's going to happen on the unit circle is you have this circle. The x, y values are going to be my sine and my cosine. So we know that sine of theta is going to be my y value. On the unit circle, you might realize that the highest y value you can have is 1, and the lowest y value you can have is -1. That's actually going to be my range. So my range is that sine is between 1 and -1. Between -1 and 1. The domain of sine, that's going to be what our theta can be. Actually, you can have any value for theta. You can have negatives, you can have positives. Think about, like, you can have negative 360 degrees, you can have negative 45 degrees, you can have positive 540. You can have pretty much any number, or you can have any number. So our range for theta is going to be all real numbers. The next function I have is cosine, and hopefully you remember that our cosine is equal to all of my x values. So the same exact thing is going to happen. You can have any value for theta, your domain. With your range, your x on the unit circle, your cosine is going to be anything between -1 and 1. These two are really, really important. You should try to remember these. That's going to be one of the things you can just memorize if you want, or definitely have it at the back of your mind. The next one I have is my tangent, and tangent, remember, is going to be my sine over cosine, which is y over x. So basically what you want for tangent is you can have any value except for x is equal to 0. So we are not going to allow x to be equal to 0. So what we're going to get is that we are going to eliminate any theta value that gives us an x of 0 on the unit circle. So for example, if my theta is 90 degrees, if it's pi over 2 right here, that gives me a 0x value. So I cannot have pi over 2. Same thing happens if it's 270, 3 pi over 2, that also gives me a 0x value. So tangent cannot be equal to that value. So I'll actually just give you the entire domain. So the domain of tangent is that our theta is going to be all real numbers except for those that have an odd integer multiple of pi over 2. So that means that you can't have 1 pi over 2. You can't have pi over 2, that's 90 degrees. You can't have 3 pi over 2. And then you can keep going around the circle. Every time you have an odd integer multiple of pi over 2, it's going to give you an undefined value for tangent. Believe it or not, the range is actually going to be all real numbers. So your tangent can be any value between -infinity and +infinity. So these three are very, very, very important, especially the sine and cosine. These three you should know. I'm going to give you the other three, but just know that the other three are a little bit less important. You're welcome just to write it down in your notes and have it. I do want you to keep in mind that cosecant is 1 over y, so we're going to be limited to values that don't give us a y equals 0. So this is going to be all real numbers except for any integer multiples of pi. And the other thing is that it's going to be almost the exact opposite range of what you had for sine. Secant, remember, is the reciprocal of cosine, and it's going to actually have the same range as what we had for tangent. The reason for that is the secant is 1 divided by x, so we want the values where x is not equal to 0. And the range of that one is actually the same as the range of my cosecant. By the way, if you don't want to write these 3 down, you might have already started, but if you don't want to write these last 3 down, they are in your book in section 6.3, so you don't need to write them down. They're not going to come up very often, but if you are the type of person who wants really, really thorough notes, then you can definitely keep this in here. So cotangent behaves really similarly to tangent. You can have all possible values in the range. By the way, since this is infinity, we shouldn't do a less than or equal to, we should just do a less than. I made a mistake the first time in that. So again, first 3 are important, especially knowing that sine and cosine have a domain of all real numbers and the range is between -1 and 1. Tangent is also slightly important. The last 3, they really don't come up that often except when you graph them, but I wouldn't really concern yourself with those 3 if you're just looking at these thinking it's a lot of stuff to memorize. Don't bother memorizing the last 3. You can write them in your notes and refer to them if you need it, but other than that, I wouldn't worry about it. So another property of trig functions is that they are what we call periodic functions. So I'll write that down in just a second, but first I'll explain what that means. So if you have sine of a value, and then you take that theta value and add any integer multiple of 2 pi, you will actually get the same value that you started with. I'll explain what I mean in just a second. The same thing happens with cosine. If you add any integer multiple of 2 pi, you'll get what you started with. And we can see that by looking at the unit circle. So for example, if you have theta equals pi over 4, 45 degrees, we know that both sine and cosine of that are equal to radical 2 over 2. Let's say now that you decide to go all the way around the circle and you stop exactly 2 pi after pi over 4, which by the way is going to be equal to 9 pi over 4. If you take the sine and cosine of 9 pi over 4, you get the exact same value. And that's going to happen no matter what if you have any integer multiple of 2 pi. It also happens with negative numbers, so you can just keep in mind that k is any integer here. This also is true with tangent. The only exception with tangent is that not only does it happen if you go around a full 360 degrees or a full 2 pi, it also happens if you just go halfway around the circle. So any integer multiple of pi for tangent will give you the same value. So for example, we know that, remember this is radical 2 over 2, radical 2 over 2, so tangent of pi over 4, which is 45 degrees, is 1. If you decide to just go a little bit further and you add pi to tangent to pi over 4, that gives you 5 pi over 4, by the way, you will get the same exact tangent. It's going to also give you positive 1. So those x and y values are different. However, because tangent is the y divided by x, if you divide a negative by a negative, you get the same positive answer. So these are important properties, and important thing to know for this is that we call functions like this that have this property periodic functions. And periodic functions, basically it just means that they repeat. There's one more important property to know, and that's finding the signs of trig functions based on their location. And we're going to look at it by quadrant. Remember, again, this is 1, 2, 3, 4. So we go around the circle in a counterclockwise direction. That sometimes confuses people. So in the first quadrant, all of my functions are going to be positive. So sine is going to be positive, so is its reciprocal cosecant. Cosine is going to be positive, and tangent is going to be a positive. In my second quadrant, my sine is positive, but both cosine and tangent are negative. Third quadrant, my sine and my cosine are negative, but my tangent's positive. And my fourth quadrant has sine being negative and cosine positive, and then tangent's also going to be negative. You can go back to the stuff that you did with your previous lesson and look at some examples of these. You did a bunch of examples where you were finding sine, cosine, and tangent and other things. Keep in mind that the reciprocals of each of these are going to have the same sign. So we remember this by, I wrote all for the first one, but I'm actually going to use that. There's a little mnemonic to remember it. So my second quadrant, my sign, which starts with S, is the thing that is positive. So we say all students. Third quadrant, my T tangent is positive, and so we say take. Calculus is a way to remember this. So the first letter of each of these words tells you the one of the three basic ones that's positive. I've also seen like the mnemonic all science teachers crazy. However, since I know that most of you have me for science, I don't think that's an appropriate one. It also is bad grammar. So all students take calculus it is. And so that's just a way to kind of remember what the signs are. So we're going to do 2 quick examples, and you're welcome to pause and try these ones on your own. So I asked you theta lies in which quadrant. We know that sine is negative. We know that cosine is negative. And you actually can just look to the left. The only place where both sine and cosine are negative is in quadrant 3. In number 2, we know that cosine is positive. We know that tangent is negative. Actually, the only place where tangent is negative and cosine is positive is going to be in quadrant 4. So these are just naming the quadrant. Don't try to do anything else.